series of the mobile computing and wireless communication. I am an instructor Varshata. Let's start our lecture series. So today topics that is going to be covered, that is GSM call routing, GSM channels and frequency allocations. So let's see this one by one. Okay, so first of all, GSM call routing. So when we are talking about the GSM call routing, you should know call routing, that means what? Suppose you are calling some person, another person. So at that time you will dial the numbers in your phone and you will just place it near to your ear. So what will happen? You are dialing the call. So that is what? It is outgoing call. Another person who is going to receive that particular call, that is what? Incoming call. Okay, so your call is divided into main process. Outgoing call, that means you are dialing the call, and incoming call, that means your friend, your relatives will going to receive that particular call. So process is divided in two parts, incoming call and outgoing call. So that is referred as mobile terminated call MTC and mobile originated call MOC. So where mobile terminated call is incoming call, that is going to receive by your friend, and mobile originated call is outgoing call, so that you are going to dial. Got it? Now here see the example for the mobile originated call. So what will happen when you are going to dial? Okay, so what will happen? For example, you are dialing the call from your mobile station. So what will happen? Using the mobile stations, you are dialing the call and that signals will be received by this BSS. So what is BSS? That is basic survey. It is a base station. Okay, so in base stations, the base station subsystem, you have BTS and BSC, base transceiver, and BSC, that is base stations controller. Okay, so this combined, it is known as the BSS. So through the mobile station, your signals will be transferred to the BSS, and BSS will send this information to the MSC. So MSC, what is the main role of the MSC? That is a mobile switching center. So main role of the MSC is what? Switching the call. Okay, so the main role of MSC is switching the call. So MSC first of all check in the VLR where that particular device will lie, where that particular device is that, in which network is that. So from where it will get all this information? So it will get the all informations from the VLR. Okay, from the VLR it will get all the informations. Okay, so from the VLR it will get the information. VLR reply back to the MSC, and MSC will check where this device is there. So according to that, it will transfer this control to the GMS, that is gateway MSC. Okay, for example, this call is of the PSTN network, public switch telephone network. So the gateway MSC that lies between this public switch telephone network and the network of that particular mobile stations. So gateway MSC will use to convert the protocol, and gateway MSC will send that particular request to this network, and from if reply comes from that gateway MSC, that will come to the MSC, and at last that will come to the BSS, and BSS will transfer this call to the MS. That means when that particular person, that is your friend or relative, receive the call, then it will establish one dedicated line. So that response will come to the mobile station, and you are going to establish the connections to that particular person. So this is what the mobile originated call. Okay. Now next is mobile terminated call. So what will happen when you call, and what will happen when you receive the call? So in last slide we have seen what will happen when you call. Now we will see what you happen when you received, or when your friend is received. So what will happen? Calling device is there. Calling devices will transfer this request to the PSTN network, public switch telephone network. Again, there is a different network, gateway. So gateway MSC will be used because the one is a mobile network and another is a public switch telephone network. So that way gateway MSC is used. Gateway MSC. What gateway MSC will do? Gateway MSC will ask to the HLR about the MSISTN number. Okay, so mobile subscriber integrated service digital network, that is the MSISTN number. That MSISTN number, GMS request from the HLR, HLR will request from the VLR. Okay, so request that MSRN number, that is a mobile subscriber roaming number. Okay, so VLR will define this mobile subscriber roaming number where the device is there. So VLR will reply back to the HLR using this mobile subscriber roaming number, and that mobile subscriber roaming number will be given as an input to the gateway MSC. So the gateway MSC will define where that particular device is there, in which network is there. Okay, so now gateway MSC is able to know where this device is there. So using that MSRN, gateway MSC will send request to the MSC of that particular network where that device is there. So now what MSC will do? Now MSC will again check. What it will check? Again it will check, it will ask to the VLR about its temporary mobile subscriber identifications number. So that temporary mobile subscriber identification number will be defined by the VLR, and that will be received by the MSC. Now using this TMSI number, what MSC will do? MSC will do the paging in the nearest basic service subsystem. Okay, so in nearest BSS, your nearest cell area, it will do the paging. Okay, so in whatever the area that particular device is there, so using that this paging channel, mobile stations will reply. So when mobile stations will reply, the authentications and authorizations will be done. So again, using this reply, this BSS will reply to the MSC. MSC will check in the VLR whether it is an authorized customer or not. If it is an authorized customer, if authentication is done perfectly, then what will happen? It will establish one dedicated line that is known as the standalone dedicated control channel that will be established to you and with your friends. So both of you can talk. So this is what the mobile terminated call. So when you are dialing the call and when your friend is receiving the call, so this process will be done in the minor seconds. Got it? So such type, this is a call routing, mobile terminated and mobile originated. Now next is GSM channel. So here you can see the different types of GSM channel is there. Which channel is that? One is a control channel and another is a traffic channel. In traffic channel, you have two types for the speech and data. For speech and data, you have two types of channel, full rate channel and half rate channel. Okay, full rate channel, that is suppose 22.8 kbps, then half rate channel is 11.4. Full rate channel is provide the best quality. Half rate channel, the quality is degraded in the half rate channel, because if your full rate channel is 11, then your half rate channel will be doubles. So when you doubles the channel, it degrades in the quality. Same way for the data. So for data, you can see it is a 9.8 kbps, 4.8 kbps and 2.4 kbps. You can use this data channel as a half rate also, but again if you use the half rate channel, it will degrade the quality. Now next is in the control channel. In control channel, you have three types. Which are the three types? That is a broadcast control channel. Okay, then you have common control channel, and then you have the dedicated control channel. Okay, in broadcast control channel, you have two different types of channel, that is a frequency correction and synchronization. Frequency correction, that means mobile stations to the base station and base station to the mobile station, that frequency should be maintained. If frequency is not maintained, if frequency is not controlled, then whatever the signals you are going to transfer, and whatever the signals you are going to receive, there is a mismatch. Okay, so that synchronization is also necessary, then frequency also necessary for this control channel. So one is a frequency correction control channel and another is a synchronization channel. Now next, another channel is what? Common control channel. In common control channel, there are three channels, which are paging channel, then access grant channel, and then random access channel. Okay, paging channel, as we have seen in the last slide, that mobile station MSC will do the paging to find out the mobile station. So at that time, it is used the paging channel. Okay, access grant channel, when mobile stations call, at that time mobile station signals from the mobile station will reach to the BSS. So basic that BSS will grant the one of the channel, so that call can be established. So that is what access grant channel. The next is a random access channel. Okay, now mobile station is calling. So at that time, any of the channel that is available, so that is randomly assigned to the mobile station. So that is what the random access channel. Okay, now next is a dedicated control channel. In dedicated control channel, fast associated channel is there, slow associated channel is there, and standalone dedicated control channel is there. Fast associated channel, when the communication is very fast, at that time you can use the fast associated control channel. When the communication rate is slow, transmission or receiving rate is slow, at that time you can use the slow associated control channel. And then next is what standalone dedicated control channel, when you are going to establish the connection between you and your friend for the talking purpose. So at that time the channel that is allocated to you, that is known as the standalone dedicated control channel. Got it? So these are the different types of the GSM channel that is used in the GSM architecture to provide the different functionalities from the mobile station to base station, and from the base station to mobile station, and between two devices. Now next is GSM frequency allocations. Okay, first of all, it used the band of the 50 megahertz. It used the FDD, FDMA, and TDMA. FDD, that means frequency division duplex, so 25 megahertz for uplink frequency and 25 megahertz for the downlink frequency. So 890 to 915 megahertz for the uplink it used, and for downlink it used 935 to 960 megahertz. Now FDMA. So 25 megahertz frequency further divided into 124 channels, one not used. So that's why this 124 channel is used. Now using the FDMA, each channel is divided into 200 kilohertz bandwidth. Now using the TDMA, what will happen? Using the TDMA, each of the above mentioned channel is then further divided into 8 time slots. So total 124 channels are there. One channel is divided into 8 time slots. Okay, so again 8 other channels are there. So you should have 124 into 8 channels. Okay, so with the combinations of FDD, FDMA and TDMA, a maximum 992 channels of the for the transmit and define and receiving purpose. So you have the maximum 992 channels. And here you can see this is the diagram for the frequency allocation. Uplink frequency is there, downlink frequency is there, and then you using the TDMA, you are going to divide the one channel in 8 time slots, and in 8 time slots you have the different types of data. Guard space is there. Guard space, that means it is used to protect from the interference. Then tail bit is there, that is defined the end of the data. Then user data is there. As for the signal strength, training is defined the encryption and decryption of the data. Okay, so likewise this data bits is used. Okay, so this is what the GSM frequency allocation. Okay, so summary of this lecture, we have learned about the GSM call routing, GSM channel, and frequency allocation. Okay, so remaining interesting topic we will cover in the next lecture. Thank you for watching. We will meet in the next lecture. Thank you.